Good afternoon, viewers. Again, I'm Teacher Betty, continuing with the molar concept under the topic molarity. This time, 2014, paper 1, number 28. 20 cubic centimeters of an acid HX was neutralized by 25 cubic centimeters of 0.05 molar sodium carbonate. Which one of the following is the molarity of the acid? We are given objective A, B, C, and D. So for this case, sodium carbonate plus the acid, we said it will produce a solid. A solid is sodium X. Carbon dioxide and water. So we have to balance the equation. Sodium this side, we have 2 sodiums, which is 2 times 1. Here we have 1 times 1, so we introduce 2. Remember in the previous lessons, I told you whatever you are introducing, put it in front of the molecule. So this has changed our X as 2 times X, come on this reactant, and also introduce a 2 in front of the acid. Then this one means 2 times hydrogen, 2 times X. So my hydrogen is already a 2. Let us look at the oxygen. How many oxygens do we have? We have 3 times 1, which is a 3. And here the total oxygen, 2 times 1 is a 2, plus a 1 is a 3. So our equation is balancing. So having balanced your equation, now you go to the question. We are told 20 cubic centimeters of the acid. Put the 20 cubic centimeters below the acid was neutralized by 25 of 0.05 molar sodium carbonate. So come below sodium hydroxide and write 25 cubic centimeter of 0.05 molar sodium carbonate. We are requested to calculate the molarity. The question mark is below the acid. So I told you always begin with the side that is having molarity and the volume, but not the question mark. So tell the examiner that moles of sodium carbonate in 25 cubic centimeters. Remember capital M, we said that 1,000, capital M means molarity, and molarity is the number of moles in 1,000 cubic centimeters. So 1,000 cubic centimeters of sodium carbonate contains 0.05 moles. What about 25 cubic centimeters of sodium carbonate will contain, we cross multiply 25 by 0.05 over 1,000, which is equal to 0.00125 moles. So these are the moles of the carbonate in 25 cubic centimeters. Now we go to the next reactant, which is the acid, which is HX. So tell the examiner that moles of the HX, or of the acid, in 20 cubic centimeters. Those moles that are in 20 cubic centimeters are always obtained from the mole ratio. This time we have the mole ratio of 1 to 2. Then tell the examiner that mole ratio of the carbonate to the acid is 1 to 2. What does this mean? We always begin with the side that we have already worked out. So we begin with sodium carbonate. 1 mole of sodium carbonate react with 2 moles of HX. What about the one we have obtained, which is 0.00125 moles of the sodium carbonate will react with, then we cross multiply, which is 0.00125 times 2 over 1. And the answer will be 0.0025 moles. So these are the moles that are in 20, but we are requested to calculate the molarity. So having obtained the moles that are in 20, we can as well get the molarity, or the number of moles that are contained in 1,000 cubic centimeters. This means that 20 cubic centimeters of the acid contain 0.0025 moles. What about 1,000? 1,000 cubic centimeter of the acid will contain, we cross multiply and then divide by, which is 0.0025 times 1,000 over 20, which is equal to 0.125 capital M, because capital M means molarity. Now you come to the objectives. Fun enough, our value is not in the same format. So you have to go on calculating over your answer, which is similar to this, is B. We have number 33 in 2004, paper 1. Lead iron react with the ions according to the following equation. We are given lead ions plus iodine ions to give us lead 2 iodide. Which one of the following is the volume of 1 molar potassium iodide solution that will react completely with 20 cubic centimeters of 0.5 molar lead 2 nitrate solution? We are told A is 5 cubic centimeters, B 10 cubic centimeters, C 20 cubic centimeters, and D 40 cubic centimeters. So that is another way of treating molarity. I told you to rewrite the reacting equation. Lead ions plus iodide ions to give us lead 2 iodide. Now go back to the question. Which one of the following is the volume of 1 molar potassium iodide? So you put 1 molar below the iodide ions. That will react completely with the 20 cubic centimeters of 0.1 molar lead 2 iodide. We are told 0.5 molar, and the volume is 20 cubic centimeters. So they want the volume that reacted with the lead 2 iodide. So I told you to begin with the side that is having molarity and volume. And then you tell the examiner that moles of lead 2 ions in 20 cubic centimeters. Capital M, remember I told you capital M means molarity, and the molarity is the number of moles contained in 1,000 cubic centimeters. So 1,000 cubic centimeters of lead ions contain 0.5 moles. What about 20 cubic centimeter of the lead ions? Will contain, we cross multiply 0.5 times 20 and then divide by 1,000, which is equal to 0.01 moles. So these are the moles that are in 20 cubic centimeters of lead 2 ions. So now we have to go and look for the moles that reacted with the lead ions. Moles of iodide ions that reacted. Remember in the previous lesson, I told you to get the moles of the opponent, always get them from the mole ratio. For this case, there is nothing in front of lead ions, so we have 1. The mole ratio of lead ions to iodide ions is 1 to 2. 1 to 2. What does this mean? It means that 1 mole of lead ions reacted with 2 moles of the iodide ions. Therefore, 0.01 moles, the one we obtained that contained in 20 of lead ions, will react with, we cross multiply 0.01 times 2 over 1, which is equal to 0.02 moles of lead of the iodide ions. So these are the moles of the iodide ions that reacted with the 20 cubic centimeters of lead iron. Now let's go and look for the volume that is contained in these moles. Volume of the iodide ions in 0.02 moles. Good enough, we are given molarity. And remember I told you, molarity is the number of moles in 1,000 cubic centimeters. Molarity is the number of moles in 1,000 cubic centimeters. Therefore, 1 mole of the iodide ion contains 1,000 cubic centimeters. What about the moles I got of the iodide ions? Will contain, we cross multiply 1,000 times 0.02 divided by 1, and the answer will be 20 cubic centimeters. Therefore, the volume required is 20 centimeters, which is needed to neutralize 20 cubic centimeters of 0.5 molar, and our answer is C. So you are going to get more examples, or we are going to calculate together more examples in UNEP in the next lesson under molarity.
Muli kuki tuli mu basi mulagawa tawuni kyannaku kikabya okabya kivo kya digito muzekwa nalogo. Eno basi tekyalina mataala, eno basi tekyalina mipiira, eno basi ndiketa za ndali. Mugive mangu temufiiramu, ne gye mulaga teriyo mulamwa, kujjako okugwa mu binnya n'okufiira mu njaga. Mubeesige yasigaza bigambo, mayimayi azunga buzungu. Muli kuki tuli mu basi mulagawa tawuni kyannaku kikabya okabya kivo kya digito muzekwa nalogo. Mwasomako twasoma luzungu, kati mukolawa tuli ku street. Mulya biki? Tulya mandazi musulirira ki? Tusulirira paani kyannaku. Muli kuki? Tuli mu baasi mulagawa tawuni kyannaku. Kikaabya bukaabya mu kivo kya digito muze kwa nalogo. Kituuka katako tuteekwa buteekwa. Kituuka katako tusaana kukyusa. Twenda pulezidenti mulala, twagala musomesa, twagala dokita bosa science atuwe vaccine, atuwe treatment, atuwe solution. Akitegedde tegeeza omulala, atategedde tukoppa bukoppi kyannaku. Muli kuki? Tuli mu baasi mulagawa tawuni kyannaku. Kikaabya bukaabya mu kivo kya digito muze kwa nalogo.